let's take a look at this, right? So you might have recognized that, or you may have done this already, right? But there are times where you have something like this. All right. Just right. Right. So there are times where they might ask something like this, right? So you might see something like it. E is equal to K V squared. And it might say, well, what is K? What's the SI unit of K? Right? In a case like this here, where we might use something called dimension analysis. Right? Dimension analysis allows us to compare the SI units on the left side to the SI units on the right side, right? If an equation is dimensionally correct, then the SI units on the left should be equal to the SI units on the right. Okay, so sometimes we use dimension analysis or something like that. So in order for you to do it, you have to know your SI units. But if I use the SI unit for energy, right? Let's say joules, and I use the SI unit for kinetic velocity, which is ms minus 1. Will that help me? Will this help me? No. I have to know the SI unit for joules in these quantities. You know it? Okay. You can work it out, right? You can work it out, right? Yeah. So if you were to take the SI unit in phase quantities in joules, we would be able to figure out the SI unit. All right. So SI units have a use besides being attached to a quantity. We could also use it to check and see if our equation correct, or check and see if we can find an unknown quantity. All right. So let's just run through this. You don't have to write this because I'm giving you this handout, right? Right. The rule of physics is to develop a better understanding of the physical world around us and make a physical world better. Right? You have all that in there, right? And I read all that. Right here, we have our SI units. These are these, right? All of these here are your phase quantities and their units. Of course, you know, yeah, you have to do these up here, right? That's okay. SI unit per mass, kilograms, SI unit per length, meters, SI unit per time, seconds, temperature, Kelvin, current, amperes. Right? This is capital I. That's okay. Charge, right? Yeah. Okay, wait, wait, just sit down here. How about you, charge it? Yeah, okay, wait, right. While saying that, for Darian jumping here. Right, so those are the SI units you have to know. Right, generally we use these SI units. Right? But I want to write it down, I'll okay with that. All good, right? I shall give left to turn this. Make sure that all this. Right, you know what moles and things. Right. Here we have some derived SI units. Right, and of course you should be able to, for each one of them, you should be able to find the SI unit. Just do one quick favor. Write down density. There's something wrong here. What it should be? Right? It should be kg ms minus m minus 2, right? Think of the S, a little bit bigger. Right, to my favor, write down the SI units for force, the base SI units for pressure, find it, and work, and power. Write the base SI units, right? Come on, let's move on a little bit. Write down the base SI units for force, pressure, work, and power. I don't want the all, I want the base SI unit for each one of them. Right, you see the message in Darida now decided from Darida number message you on it, guys. Your WhatsApp number, right? Anybody else need enough here? Everybody name here, right? Videsh? Pronounce the name right? But that is D. How do you pronounce the name then? Or Vignesh, I think Vignesh. And Marquis. Okay. Pronounce it wrong. Comment tu pronounce it? That's not it. Sorry. Just try to create units. All right. Let's see what you have, right? So SI units for force, right? In terms of base quantities, we already have it here. The SI unit for pressure, well, I could take off force, right? And you will get kg m to the minus 1 s to the minus 2. Everybody have that? Right? I just took off newtons. I took off newtons and I wrote kg ms minus 2 by m to the minus 2. And I simplify the m's, right? I simplify the m's, right? 1 plus minus 2 is minus 1. Everybody okay with that? So the SI unit base quantities of pressure is kg m minus 1 s minus 2. Okay. Right? Joules is Newton meter. So that will be kg m squared s to the minus. Okay? Because you multiply this m by this m again. These two m's and I get m squared. Everybody okay with that? And last one is what? Last one is joules per second. So that will be kg m squared s to the minus 2 over s to the minus 1. right? So that will become kgm squared minus 2 minus 1 is minus 1. Okay with that? Sure. Minus 2 minus 1, right? Minus 2 plus 1, which is minus 1. Okay, so these are the base SI units, we need them, right? For all the questions that we're going to do, we'll need them, right? Okay. Done now. Sorry. It is not to the negative. Oh, yes. That should be positive ones. Sorry. I write down the wrong thing. So yes, you are right. Negative 2. I was wrong. Sorry. S to the minus 3. I wrote down the wrong thing. Okay, so those are the units that we need to know, right? So we're going to apply those now. By the way, so what will be the unit for kinetic energy? Same as work, right? Right? What will be the SI unit for potential energy? Same as work. Okay? Yeah? All right. So how we going to online? You are okay there? Katrina, are you okay? Yeah. You are listening, right? You are all right. Right. So dimension analysis, right? 3 uses. The first is dimension analysis may be used to check homogeneity. Homogeneity simply means units on the left, units on the right should be equal. It does not mean that the equation is correct. Right? So I have a quick question here. Is this homogeneous? Right? SI units for kinetic energy is what? We just saw it, right? kg1. Right? Let's check the right hand side. Mass is kilograms and velocity is ms minus 1 squared. When I square ms minus 1, I'll get kgm squared s to the minus 2. So are the units the same? So they are homogeneous. But is the equation correct? No, the equation is not correct. So homogeneity does not mean that the equation is accurate. Right? It's missing constant. That's okay? So dimensionally correct. But the value is not, but the actual equation is not accurate. Okay? So the first application, check and see if the equation is homogeneous. Second application, I'm gonna have all that data after right, right? We have a few to try. We'll do a test now. The second application, where is B? The second application, we can also use it to develop the equation. So I can take this information here and I can develop an equation, right? And I'll show you this, right? I'll do it on code. This one not popular. First one is the most popular. And the last application of dimension analysis, it may be used to help working out a problem, right? So for example, let's say you got a quantity. Let's say in a question, you got 5 kilograms per second, right? By knowing SI units, what does this tell you? This tells you that you're using 5 kilograms every second, correct? So what you have here, you really have mass divided by time, this here, correct? Yeah. So just suppose you had a formula. Q is equal to R by M on T. Can you see where M and T comes from? M and T is this here. Okay, so by looking at the SI units, you can figure it out, right? I'm not sure if you all remember this in nuclear physics, where sometimes there's give you the greater loss of the mass, and you have to print power, something like that, or energy, right? So here's an example of where you have to take a look at the units and see how the units can help you in the equation. All right. So in this case, they didn't give you a mass and time. What they gave you was mass divided by time. Right? Let's try. Right. I'll give it. I don't walk back there anyway. All right, so let's see if we can try one or two of these, right? Try number. Try C and try C. No, sorry. Try B and D as in door. You probably have the hat. We have it out with the answer. I don't want to give it out. I want to give it back. But I do want to put the answer. Come on, try B and C for me. Check the unit on the left and the unit on the right. Okay, and tell me if they're homogeneous or not. Ready? Yes. check out the first one. Pressure is what again? Pressure is kgm to the minus 3. M or M squared? M to the minus 1, S to the minus. All right, nice. The pressure power. Come again, M to the minus 1, S to the minus 2. Right, and let's check out the right hand side now. Right, so the right hand side density is what? Mass over volume. So that's kgm to the minus 3 multiplied by gravity, ms minus 2 multiplied by s to the minus, multiplied by height z. So I only have 1 kg. I have m here, that's m squared, and here m to the minus 3. So that's minus 3 plus 2, and there is only one s, so I put in s to the minus 2. So I bring all the m's together, I bring all the s's, I bring all the k's together. When you work it out, you will end up with the same thing, right? Kg m to the minus 1, s to the minus 2. Right? So therefore it's homogeneous. Right? Try D now. That's P. So for D, we know the SI unit is ms minus 1. Check and see if this formula here, right, if it makes it homogeneous or not. I told you what E is, and I told you what the density part is. Try that in. I'll do them for just now, right? Remember, E is force over area, density is mass over volume. You check in to see if when it's simplified, it gives you. Take your time. Try that one next. Hi, Rusty, what's up? What would you guess? All right, ready? I just switch into the board for this one, right? Gonna make sure we simplify it out properly, right? Right hand side, force on area, and underneath there is density, right? So I just doing it part by part before I put it together. E is force over area. Anybody recognize that? Force on area is pressure, right? So that's kgms minus 2 all over m squared, right? So you will end up with kg m to the minus 1 s to the minus 2. That's okay? Build it up for E. Yeah? That's how we have the pressure, right? And right. Same thing, right? And now we know what density is. Density is kgm to the minus 3. Okay? So I'm going to put them together now. Right? So I'm going to put them together. E over density is kgm to the minus 1 s to the minus 2 all over kgm to the minus 3. Everybody okay with that? But what do we have to do? We have to square root. Square root means what? To the power of a half. Right? But what happened with the kgs? Kg will cancel, right? So to the power of a half, we will have m to the minus 1 plus minus 3, sorry, minus 3 s to the minus 2. So I got m squared s to the minus 2 all to the power of a half. Good. Are you okay with that? Yeah. And now 2 by a half minus 2 by a half, we get in ms to the minus 1. 2 by a half is 1, minus 2 by a half is minus. So this and this equal, therefore, left hand side equal to right hand side, therefore, homogeneous. Online, are you okay there? Raj? Very smart. Comments are please. Tell me if you ready. Raj? All right, are you okay with us? Everybody okay with us? Right, so you recognize the carry on from marks, right? Remember in the series on. Next one. Let's try 1-1 and I can show you some class peoples. Yeah. Yes. Yes, ma'am. How can I help you? Try E. Period. Last one. And then I'll switch it up. Yes, ma'am. E, right? Do you want part E? Part E there. Huh? With two pi have an SI unit. With two pi have an SI unit. No, that's not right. So no SI unit, right? Here, period seconds, right? So look at that. Okay, homogeneous or not? No, fit, homogeneous. Oh, it's not. Online, what you all got? Message going again. Homogeneous or not? Right, number period is in seconds, right? Right, let me see what online got there. Wait, online or the same thing? Yeah, just message it with homogeneous or not. David get homogeneous, nice. Wait, guys. Homogeneous. Yeah, take up. Yeah. Right? So two pi no SI units, so you can totally ignore that. But not totally. Right? Square root is to the power of a half. And L is what? L is in meters and gravity is in what? So the M will cancel. So you'll get 1 over s to the minus 2 all to the half. What does minus 2 mean again? Right? I just writing it here. So it's 1 divided by minus 2 means 1 over s squared. Correct? And when it flips some multiply, you'll end up with s squared. Okay? So inside here is really s squared to the power of a half, which will become s. So therefore, are they the same? Yes. All right. Let's try pass the paper. Let's try a little pass the paper, right? Are you okay with that? right? When the document finish out send it forward, right? Just stop it by topic for the module, right? Right. Right, June 2014. Are we in the right now, everyone? That's no one, that's just making it subject to the formula. But we realize that? What's it here? Just making subject to the formula, right? In fact, do it so. Yeah. Do it so. Making sense something there. I'm missing that formula then. Anybody remember it? What's the formula that can help you link two of them? Okay, how you find speed of a wave? V is equal to what? F lambda, right? F lambda. And F is what? And it equals to what? Besides that, formula for find frequency is what? Just one answer. Right, go ahead. Show that in. Show that in. It's not really dimensional, it's really just rearranged, not form. Do you think it? How many bonds is one of us in bench? Come on, wait. Double. So I make T subject at the formula. Right, how to figure this? It's not here, right? V is lambda. Okay. That's what hypothetical give you. Can't give you more on that. Without trouble. Between you and Dario. What Dario? Anybody else new account? What are them always saying? So you, huh? All right. Let's see what I get, right? What do you get? You're right, man. Right. Right. Let's see what you got. We're trying to make T the subject of the formula, right? So T is equal to lambda and V. Let's cross multiply and make T the subject, right? Next. We know what V is, right? So it will be lambda divided by V, which is the square root of G lambda on 2 pi. Everybody okay with that? Huh? So now T is lambda multiplied by the part the fraction you'll flip over. So you'll get the square root of 2 pi over G lambda. That's okay? Right. Problem now is to simplify the lambda out. All right. So what you can do, there are two things you can do. If I wanted to bring the lambda into the square root, what would it become? 2 pi by what? Lambda what? If I want to bring the lambda into the square root, it becomes lambda squared. This lambda will cancel here, and I'll get it the square root of 2 pi and G. Sorry, 2 pi lambda and G. That's okay? I bring the lambda on the inside. No man, you don't like that? So what to do? Put lambda on the outside. Okay? So this here is the square root of lambda. So if I bring it on the outside, it will be lambda over root lambda. And what you'll get? Root lambda, right? Then I can put it back there. But don't like that. Just bring the lambda inside the root. Right? If you bring the lambda inside the root, then this lambda becomes squared. All right? 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 So bring a lambda inside the root, it becomes lambda squared. Okay, next one. Next one, after you copy that down, we just have one more to do here, where we have to not develop the formula. Last thing I put on here, show that both sides of the relation have the same fundamental units. Show that both, yeah. Yeah. Show that both sides.
Like, I have a question. Last question.
Yeah. Oh, you don't about it? No, right? If you're lost, right? Those who look at the camera, right? Online, if you're lost, look at the camera. Those who are not lost, start that one there fast. Right here. Those who want to just look at the camera, right? So it was B is equal to the square root of what? G lambda over 2 pi. Right? Lambda tomorrow came before so let's see, right? B is square root of G lambda on 2 pi, and they want you to find T. Right? I told you that V is equal to F lambda and V is equal to lambda on T. Right? because frequency is one period. Correct? So you okay with this? So if I cross multiply and switch them, I'll get T is lambda on V. You okay with that? So writing that here. T is lambda divided by V. Now, T is equal to lambda multiplied by, divided by what they gave us here. G lambda on 2 pi. Right? So, if I had to switch this divide and multiply, this is technically a fraction, right? This is technically the square root of G lambda over the square root 2 pi. These two are the same thing. So if I flip this over, I'll get the square root of 2 pi all over the square root of G lambda. You okay with that? Right. The problem is I don't want to work with this, I don't want to leave this lambda like that. So lambda is the same as lambda squared, square root the whole thing. Correct? So now I can bring these two together. So I'll end up with T is equal to this multiplied by this is lambda 2 pi lambda squared. Right, okay? Lambda 2 by lambda 3 is lambda 6. So lambda this by lambda this is this. Just multiply the things in here. Right? All over G lambda. Right? I'm leaving it as a whole square. You okay with that? Now this lambda will cancel for this. So you'll get the square root of 2 pi lambda all over G. That was the answer, right? Everybody okay with that? Yeah? Let's try this next one here. Right. This one here, check and see if they are the same fundamental units. You might not recognize all the quantity because this is modern tree, right? P is pressure. V is volume. N is a constant, it's number of particles. You're gonna ignore that, right? M is mass. And C to the minus 2 is speed. C is speed. Right? C is speed, like ms minus 1, right? Try and see if the SI units are the same thing. Cover? Sidana? Cover? For sure. Try this one here, right? This is module 3 things. P is pressure, V is volume, N is a constant, M is the mass, and C is speed. Check and see if the SI fundamental quantities are the same. Left hand right. So right on left hand side, work it out. Right on right hand side, work it out. You'll kind of like the whiteboard more than the writing then. Finish. Okay, go. Homogeneous. Yeah, check and see if the units on both sides the same. I know I move off still. Watch it here. Show that both sides have the same fundamental units. So you just check it to see if they're homogeneous. But it's a proof actually. Anybody get it? David saying non-homogeneous. But the question says show. Okay, right. I think that type that bad. Not -2, it should be mean square, +2. That's slashing the wrong place, type it back. It's called mean square. Right? It's not c to the -2. It's c mean square. Right? That's what it's called. Don't worry, you just use positives. Yeah, the average, just c square. Yeah, so forget that. Take off that minus sign there. That was a mistake. Right? You do that positive, right? Because you slash the point in the wrong place, right? Okay, all right, David. Anybody able to mark Olympia? When is getting past it? So in other different levels or the everybody will see them down. That's senior and junior, some it's getting past it like that. So if I go on and I was there. And the exam that we do here is Australian version or the UK? The Australian. I Canadian. Yeah, it's a big conference. Well, some do that number, there's some fast. But if you will have all right, nice. I can check someone. Oh yeah, a couple of classes I might have to book online, right? I'll try to have a little queue problem. So I can't stand and walk on Sunday. So I'm trying a new thing for 2 weeks. So if I end up getting shots on a Friday, I'll still take one that do online. Right? I think I feel like I'm better about it. I have done my kiddies last year. And I don't as well. So now you're not good. I'll try something. All right. Let's check this out. So they get homogeneous now. So let's see what we got, right? Left hand side is PV. So pressure is my margin order kg m. Pressure is what? M to the S to the -2. And volume is m cubed. Right? So this is kg m squared S to the -2. Now I can take the right hand side 1/3 n m c squared. Right? As I said, they made a mistake. This dash should be here. Right? 1/3 no SI unit, n no SI unit, m kg, and s and mean square will be ms minus 1 squared. So that will be kg m squared S to the -2. Are they the same? Yes. So therefore homogeneous. Yeah. Right? Sometimes now they will give us a question like that and say, okay, well, find the SI unit for n. Right? So they will tell you the equation homogeneous and they will work backwards now and find the SI unit for n. Okay? So let's try some of those. Online, everybody okay? See that?
Oh, what's it?
Oh. Garage again, Troy. Right. Take a look at the one they gave us there. Right? Take a look at what we have here, right? Terminal velocity V of a lead spare is given by that. Right? Don't get confused with terminal velocity, it's just normal velocity. Right? So let's just make sure you know all the quantities. Velocity, mass, gravity, 6 pi, K is what we're trying to find, and R is radius. Okay? They would like you, they gave you this formula. They would like you to determine. Right. They would like you to determine the units of K. So this question is the reverse. We know that this is correct. We know it's correct. They want you to find the units of K. While do that. Lexicon somebody, Gavin. Take a little read. What do you think? How you will find we know the equation, right? And yeah,
So if I put in that hand side, right?
right.
Now when you find that, you're kind of trying for the right hand side too. And whatever is missing on the right hand side and on the left hand side, it'll be
Okay. Anything else? Anything else we can do because we know the equation right? Online? Make it subject to the formula and then find it. Right? But that can work as well, right? That can work as well. Right? But the better thing, easier thing to do is to make K the subject and find the SI units. Alright? Go ahead, have fun, do that fast. Let me get squeezed in the next one. I like 75. Yeah, V is just velocity. M is mass, G is gravity, R is radius. So make K the subject of the formula and work it out. Even finish it. Put the chat in here. 9 pieces. I can leave it as a man finish. Yeah, make K the subject. Huh? Yeah, you don't need it. Okay, you want to see the whole thing? It's 2000. It's a long class. You're present. Yeah. You're done? Huh? She no, she didn't assume. She didn't say nothing. All ready? Make it the subject and then let's see what you got. We have one more to do before coloring. Right, so if you make K the subject, we could cross multiply, two fractions, cross multiply. And you will get VT, which is velocity, by 6 pi KR mg. Right. So therefore, K is equal to mg. No, I don't know why. Right, so when you work it out, you're supposed to have mg all over 6 pi VR. That's okay? And m is in mass, so that's m. That's not okay. Right, so m is mass. So that's P. All right, so K is equal to what? Mg over 6 pi KR. So focusing on the right hand side, units only, right? VR. So that would be kg ms minus 2 all over v ms minus 1 r is that. That's okay? So the SI unit for velocity is this. R is radius. So that's meters, right? That's okay? Yeah. So the meter will cancel. And I will get kg s to the minus 2, right? Minus 1 m to the minus 1. So I am getting kg m to the minus 1 s to the minus. That's okay? So that's the unknown quantity there. That's okay with that?
Yes.
Can we get squeezing one more?
Yes.
Ask. All right. Here's all the close. All right, so we'll do a few more next year and we'll go on to resolve it for something afterwards, right?